Okay. There we go. So let's make sure we're caught up with what's happening. Your exams, I'm falling behind on you guys. Sorry, I didn't get to look at them this weekend. This weekend was catch up on sleep weekend. So we took the test 21226 here. Okay, we're doing 28 here because we were supposed to do 28 here. We're going to do 29 and 10 here together. We've always done it together anyway, so that's not going to be that big of a deal, I don't think. Even if it is that big of a deal, we got 211 here, 12, and then we got a 13 and a 13B. We actually end up with an extra day before Thanksgiving. That's why it's orange. So there's an extra A day. That's extra B day. We're A days. Oh, we're in trouble. Oh, never mind. We don't have an extra day. B days have an extra day. Okay. Anyway, just kind of follow along with that today. I have for you guys, now I know we did 2-7 before. I didn't even look at your 2-7s, whether you turned it in or not. You have a 2-7 worksheet, okay? So I do know that about half of you guys at least turned it in. But 2-7 is down here. It's farther away. That Wednesday right here, here's 2-7. So make sure you turn that worksheet in there, okay? And then I've assigned the 2-7 Delta, and I got it due Wednesday. So 2-7 worksheet, 2-7 Delta, and 2-8. You're going to have a lot to do between now and Wednesday. Some of you don't have much to do at all because you've already done the other two. But those things are going to be due by Wednesday, okay? If you can't get it done by Wednesday, let me know. But that's kind of what I'm expecting. All right. Some of you guys are getting pretty bad about not uploading your stuff. I want it uploaded, not just because it's just a habit. I like to be able to, on a test, go back and look and say, man, they didn't have a clue how to do this question. And I go back to the homework. And that just allows me an easy way to go back to the homework and say, they could do it there. They couldn't do it here. I don't know what happened between here and there. And that tells me one of two things. You didn't study well, or you didn't really know how to do it on the homework. Does that y'all kind of follow along? But that's just a check for me. That's the reason for you guys uploading it more than anything else, is I can always go back and look at it. And it's a whole lot to go back and look at it electronically than if I had a stack of I don't know how many homework papers. Okay? Plus, you guys get to keep them, which I think is advantageous to you to have them in your hands always. So that's the reason for the uploading more than anything else. So you showing it to me saying you did it, yeah, that's okay, but I can't go back and look at that and compare that to a test question. So that's why I want you guys to upload it. So let's kind of get back into the habit of doing things that we ask. All right, here we go. 2.8. This is a pretty long lesson. I do think you know this information. We've talked about inverses of functions and special things about that, okay? So, follow along. I do not think this is that difficult. However, it's one of those type of things that it gets difficult on the AP exam or on your exam. I don't think the homework's as bad as the actual exam questions. So that's one of those things that, let's see, how do I say this? Knowing how to do might be a little bit different than knowing what to do. Okay, inverses. If you remember, 2.7 now was the composition of functions, right? F of G or H of G or F of F, those composition. And you got to know the composition in order to do some inverse things too. So we'll pull that up. An inverse of a relation will undo a given relation. Every inverse can be found by switching X and Y. Switching. If you can remember basically switching X and Y about every time you see an inverse, it switches domain and ranges, it switches X's and Y's, it switches points, it switches graphs, everything gets switched. All the X's are now Y's and all the Y's are now X's. In some situations, this process is intuitive. Other times it may not be as obvious. In these cases, it's appropriate that we understand the of inverse relations. I don't know. You understand everything about them. I don't know. Understand the properties of relations. I don't know what that means. Obviously, it's important. There are three ways we got to look at these: numerically, graphically, and analytically. Okay? Numerically is with tables. That is absolutely the easiest thing to do because you have X values and you have Y values. And if you want the inverses, we're now going to make the Y values the X values, and we're going to make the X values the Y values. So that's probably about the easiest we can possibly do. Graphically, almost the same type way. Some of them are a little bit harder than others. We'll look at that. But basically, if you have a point, whatever that point is, XY, it's now going to be YX, or it's now Y. Okay, you're switching that XY. So if it's 1, 2, you're going to make it 2, 1 and put a new point. So that's not too bad also. And then equations, that's when it gets a little difficult because you got to switch X and Y, and you can switch X and Y really easily, but then you got to solve it for Y. And that's using algebra that sometimes gets a little difficult. So take that off. Find the inverse relations of the given table. And again, we kind of already said that. This is X and Y. That says X and Y over there, but if I want the inverse, I'm just going to switch these. So instead of 1, 3, 4, 6, the 1, 3, 4, 6 is now going to be my Y values. And the -1 and the 2 and the 0 and the 2 are now going to be X values. So switch X and Y, switch X and Y, switch X and Y. With tables, it's very easy. Okay, with tables, it's very easy. And this will come up at some point, this is a function. This is a function. For every input value, I have exactly one output value. Sometimes the inverses are not functions. Sometimes the inverses are not functions if the original was. Just be aware of that, okay? For instance, this one is not, right? You have two input values that are the same that are giving me different output values. And you can't have that. So at 2, I can't have a 3 and then have a 6 also because it's now no longer a function. You have two different Y's for the same X. Fair enough with that? Just recognize that. They didn't say anything about it. They just said find the inverse. So just recognize that. Sometimes they'll talk about that. The original table. Oh, here, that's what this says. I'll be darned. The original table is a function because each X has exactly one Y. However, the inverse is not, because we have what? 2 outputs for 1 input. 2 outputs for 1 input. There are several ways you could say that, but that's probably the best way you could say that. Because for 1 output, for the 2 output or the 2 input, you have a 3 and a 6 output. So just recognize that sometimes that happens. Okay. Now we have graphically. There we go. Here's graphically. Sketch an inverse of the given equation. And what I do, guys, is I just switch the points. So this is -2, -1. That's -2, -1. So if it's -2, -1, I'm going to -1, -2. -2, -1, -1, -2. That's -1, 2. So I'm going to go to 2, -1. This is 2, 1. So I'm going to go to 1, 2. And the last one is 4, 3. I've got to go to 3, 4. Yo, yippee. Now I got to connect those stupid things. Did I do this one? -2. That was this point. I don't think I'm doing that. I think I'm doing this. Nope. That looks stupid. It was which way? This way? There? There? There. Second one is not a function. List the key points, create a new table. Okay, plot it. Is the original function, oh, is the original relation a function? Yes. Is the inverse a function? No. Okay. Bless. It comes up. Let me just do it. I'll just do it when it comes up. Graphical properties. Okay, this is important to know. The graphs of inverses are reflections over the line y equals x. I mean, y equals x, x equals y, y equals x, x equals y. So if I drew a y equals x line, I know this is a little weird because you guys, I mean, that's probably one of the easiest linear functions to draw. Y-intercept is 0 and the slope is 1. But we're not used to seeing it like that. But 3, 3, 3, 3. That's the line y equals x. That's why this point is right on it. This point is reflected here. This point is reflected here. This point's reflected here. It's reflected over the line y equals x. And so if you can picture taking this graph and folding it on that origin, that's the imprint we get. It's I call it a flip. Flip it on the x, then flip it on the y. So if you flip this on the x, then flip it on the y, that's that point. Flip that one on the x-axis, then flip it on the y. There it is. Whoop, 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 that can't be it. Where'd it go? It's over here. No, it's here. Sorry. I'm confused now. Flip it. Switch points. I get confused on that. You guys do better on that than I do. Beautiful, 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 beautiful. This one's the harder one. This is not bad at all here. Some of these other ones will get that way. Find the inverse. This is now analytically or algebraically, if you will. So it's now, instead of f of x, I'm going to actually put like y equals 3x minus 7. Well, we already know that if I'm going to find the inverse, I got to switch x and y. So we'll make this now x equals 3y minus 7, and then you have to solve it for y. You have to get y by itself. So I'll move the 7 over here. Divide everything by 3. And so y equals, and you can make that x over 3 plus 7 over 3, or you can leave it as x plus 7 over 3, or however you want to do that. But then we got to write it like they want me to. And so what they're going to do, instead of putting y equals this, now I'm going to change it back to f of x, but I'm going to do f inverse of x. Some of you guys saw that on that one, those homework questions, right? We talked a little bit about that. You guys saw it. I know you guys saw inverses in Algebra 2. I know that confused you because you saw it before we talked about it. But they'll always want you to write it to the -1 power, okay? And it's the f is to the -1, the x is not. So don't put the whole thing to the -1 power because that just says it's something different. There it is. The inverse is written as f -1 x. Switch x and y, solve for y. Get it by itself. If the original equation is in f of x form, write the inverse in f inverse of x. If it's g of x, write g inverse of x. H of x, h inverse x. Very important that you write it correctly. They even put reminder, f of x equals y. Beautiful. Some of those are really easy. We'll get to some that are a little bit more difficult. Okay. Multiple x's. If you don't know how to do it, look at these steps. I'm not going over these steps. They get a little bit harder. Okay? Find the inverses. Well, the first thing we know, we got to switch x and y. So now instead of this being y, it's going to be x, y minus 2, y plus 3. Okay, so a little bit harder to solve than just a simple linear. Multiply both sides by y plus 3. I'll show it. I typically don't. Blue. There it is. Y plus 3, y plus 3. So I'm left with, can I go ahead and distribute that? Was that going to mess you guys up if I distribute that? xy or yx, either way, plus 3x. I distributed that. And now it's equal to y minus 2. If I skip too many steps, make sure y'all know that. But multiply this side by y plus, if I multiply that by y plus 3, they cancel out. If I multiply this by y plus 3, you got to distribute the x. Our goal is to get y by itself. So I got an xy, I got a 3x, I got a y, and I got a -2. And I got to put the y's on one side. I don't care if I'm going to put them on the left-hand side or the right-hand side. I'm going to put them on the left-hand side. So this is going to be an xy. This is now going to be minus y. Whoa. Say what I'm doing and not what I'm writing. Subtract a y, and then this is going to be a -3x, and this is going to be a -2. I probably should have put everything on that side, and then I would have gotten rid of a bunch of negatives. But it won't matter. I should have put this xy over here and put that 2 over here, and then I would only have one negative sign. Currently, I have 3 negative signs. Just recognize those things. It doesn't matter, but it's just, I don't like negatives. Now this has a y, and this one has a y, and this one doesn't have a y, and this one doesn't have a y. I got to get y by itself. In order to get y by itself, I got to get rid of these y's. In order to get rid of these y's, I got to factor the y out. So I'm going to factor it out. And if I factor a y out of an xy, I'm just left with an x. And if I factor a y out of a -y, I'm left with a -1. You've got to be able to distribute that to get what you started with. Because if you can't, you didn't do it right. I'm not changing the value, I'm changing the look. Over here, I'm not going to do anything. And now to get y by itself, I've got to divide it by the x minus the 1. So divide this by x minus 1. And if I divide that by x minus 1, I got to divide this by x minus 1. And this equals, what was it, f of x? F inverse x. You got to be careful with your Y's and your X's. You got to be careful with your Y's and your X's. Don't make an X look like a Y and don't make a Y look like an X. Be careful. That's why I tend to put curly loops on my Y's. This is not the only answer. You could have gotten 3x plus 2 over 1 minus x. Basically, all the signs be changed. Okay? If all the signs are changed, it's the same thing. They don't care which one you got. They don't care, but just understand that if you're trying to check an answer and you got all these signs different than yours, yours is still right. Second one works almost the same. Y'all start it. Y'all start it. The first move is worth a point. Try to finish it if you can. Whoops. Hopefully yours looks close to mine. Did I mess up somewhere?
I don't know if it's just the way it's set up, but I've noticed for that both A and B, you just switch the second number on the bottom denominator and the first number, first coefficient. That becomes 3x minus 2 in the exponential. That one became 3 on the top and 1 on the bottom.
I'm not following you where I messed up.
So g of x, you didn't mess up.
Oh.
2x plus 1 is x minus 3. We put 3x plus 1 and x minus 2. The 3 and the 2 switch. So then the first one, 1x minus 2 and x plus 3 became negative 3x minus 2 and x minus 1. And that's because we had a negative 1. Negative positive. Positive 3.
Did I mess up?
No,
oh, okay.
Is the way it's set up, or is it always like that?
Oh, it's kind of always like that. I hear your question now. I'm sorry. I was not following. There's a reason why we've done 2 of these just like this. Y'all kind of follow? Other than one linear. The linears are easy. You can flip-flop a linear pretty easily. It's when you start getting denominators like this, you have to start doing some factoring. And because the inverses, yes, those pluses and minuses kind of do some changing around. I don't recommend, trying to find a pattern. You're just better off trying to solve the thing. I hear what you're saying now. Okay, now I'm following. Again, we talked about this could be negative 3x and negative 1 and a negative x and a positive 2. All of those could be switched and you'll have the same answer. This time I tried to not do the negatives. Everybody okay with it? All right. More on graphing inverses. We know to find an inverse, we simply switch x and y. Graphically, this means the function and its inverses will be reflections over the line y equals x. Or x equals y. It doesn't really matter how you put that. If a graph is made up simply of line segments, sketching the inverses can be challenging. Obviously, I showed that earlier. To do this, we use the fact that a function and its inverses are reflections over the line y equals x, and this helps us sketch the inverse of a function sometimes. So sometimes what might be helpful to you, steps to sketch an inverse graph. This is not the only way to do it, but it's nonlinear. Sketch the line y equals x on the graph. If anything, that's at least going to help you to show the grader that you know what you're doing. Now, you may not show them how to do it, but you know what you're doing. Mark any points from the original graph that are already on the line. This will make more sense, I guess, when we do it. These points will stay the same. Select a few additional points on the original graph and find their inverse points. You can find the inverse points by switching x and y, or by graphically reflecting it over the line y equals x by drawing the line perpendicular. I can't spell perpen, E-N. Sketch the inverse by connecting the new points. This is one of those type of things, guys. I don't care how you do it. You just got to get it done. There's not a, like, I got to do it this way. Sketch the inverse below. What I'm going to do is I'm going to look at 2, 0. And if it's 2, 0, I better go to 0, 2. So this point will now be this point. And if I really wanted to be good, I guess I'd sketch that y equals x line through there. And that point will stay the same. And this point will stay the same. Because whatever that point is, in fact, that one's what, 4, 4? And if I switch 4, 4, it's 4, 4. That's 4, 4. I switched 4. This is 1, 1. Oh, that's nice. That's 1, 1. And switch it to 1, 1. So that's why these points stay the same. This point is 0, 4. So 0, 4 is now going to go to 4, 0. This is getting confusing. That point's not on there. Beautiful. Is there another nice point on there? 1. Where? 3. Oh, 3, 1. 3, 1 will now go to 1, 3. Can y'all kind of see what this is going to end up doing? I guess it continues on. Beautiful. I just switched the points. And if you have to, this is like 3.5, 2.5. So 3.5, 2.5 will go to 2.5, 3.5. I'll be honest with you, sometimes you guys, there's many of you guys that are better at that than me. It's hard for me to visualize that. You can draw them perpendicular. In other words, I go straight up here until I get to that point, and then go straight across. Go straight up, go straight, well, no, here's the point. I'm sorry. I'm sorry. Go straight up, go straight across. That's what they mean by the perpendicular. Straight across, straight down. Make a square. Did y'all get that one done over there yet? Always draw that to help you. Rather it helps you or not, draw it. Rather it helps you or not, draw it. If it's a free response question. Y'all follow what I'm saying on that, right? If it's a free response question, at least draw that line. If it doesn't help you, still draw it. Oops. And those points stay the same. That's 1, 0, so I need 0, 1. That's -1, 2. I need 2, -1. What else is there nice? -2, 0. -2, 0, 0, -2. Beautiful. I'm going to need help. This point is staying that point. And I'm curving it on till this point. Let's see, let's go perpendicular. Boom, boom. I'm confused. Down, curve, concave up. Here? I don't like these because I don't like them when they're not functions. Go back here. Beautiful. Yuck. Oh, I guess I need to finish this. That's beautiful. It's ugly, but it's beautiful. Y'all have used patty paper before on some of these type of reflections? Yeah. Just kind of picture that. That's what you're trying to, just as long as you can somewhat get close to that. Yeah. I don't like them when they're not function. That just always confuses me. But you guys are better at that than me. Beautiful. If you plug a number into the function, it generally output a different number. When you input some number, generally it outputs a different number. Sometimes it's the same. For example, if we plug a 2 into the function 3x plus or 3x minus 1, we'll get 6 minus 1, we'll get 5. Everybody good with that, right? Plug in a 2, you're going to get a 5. Now, if we plug that answer into the inverse, we better get a 2 because we switched our x's and our y's. This was our x, this is our y. Now, if I'm plugging in my y into my inverse, I better get the x. This is because an inverse function is simply will undo a function. So if we plug a x into the function and output inverses, we should end up with x again. Yep, both of those are x's. So if we plug x into a function and then plug the output into the inverse function, we'll end up with x again. This is when it starts becoming a lot more confusing. You know these answers and you know what this is doing, but when they put it in words, it gets really confusing. So picture that kind of a type thing on the test. Output, input, input, output. If I input this, I output this. What happens with that output? The output now becomes the input. Okay, it can mess with our brains a little bit. You got to slow it down and read it piece by piece. two functions, f of x and g of x, are inverses only if and only if, f of g of x equals x and g of f of x equals x. So this is where we're having to use 2.7, the composition of functions, to prove inverses. To show that two functions are inverses, we must show that f of g of x and g of f of x both equal x. You have to show both. Many a time students only show one. I remember this being a free response question. So this is a free response question. Show that these two are inverses, or they might even ask, are these two inverses? So star that, whatever you got to do. I just remember that being, I remember a lot of students showing f of g of x, but they didn't show g of f. And that didn't give them full points. You got to show both. All right. Example number 6. Let f of x equal 2x minus 3. Let g of x equal be 1/2 x plus 3/2 be functions below. Determine if f and g are inverses. So step 1, find f of g of x. So that means I've got f of x here. I've got to put this in place of that x. So I've got 2, and instead of x, I now have g, which is 1/2 x plus 3/2, and then don't forget the minus 3. Now we're going to simplify. We're going to distribute, and that's really, really nice, because if I do 2 times 1/2, I'm going to get 1, and then 2 times 3/2, I'm going to get 3. So I'm going to end up with x plus 3 minus 3. Wow, that's really, really nice. I end up with x. So far, it's looking like they are inverses of each other. I will give you a heads up. I have never seen it work here and not work here. Y'all okay? I mean, if it works here, it's going to work here. If it doesn't work here, it won't work here. So if it works and you don't get it to work, you've done something wrong. So now I've got to do the opposite of this, or the flip of this, or however you want to say it. So now I have to take f and put it in place of g. So now I have 1/2, but instead of x, I now have f. 2x minus 3. And then I've got to do plus 3/2. And I think we can kind of see already how this is going to happen. 1/2 times 2 is simply 1. 1/2 times -3 is -3/2. And then I got a positive 3/2. Beautiful. So f of g equals x and g of f equals x. Therefore, those two are inverses of each other. I don't think they're that easy on the test. I don't think they're linear. But we'll get some practice on that. Don't do some magic math and I see scribble, 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 x, x, x equals x. Y'all kind of follow what I'm saying, right? I got to be able to follow what you have done mathematically. Okay? Sometimes we must use a restricted domain to ensure the two functions are inverses. Officially, guys, a function does not have an inverse if the inverse is not a function. I didn't learn that until 2 or 3 years ago. I always thought everybody had a function, just some of the functions were not functions. Some of the inverses were not functions. Sometimes we show that h of x and k of x are inverses when k is greater than 10. Well, we have to understand that k needs to be greater, or the x has to be greater than 10, because if x is not greater than 10, this one's imaginary. Okay, so that's kind of why they're putting some restrictions out there. Most time when they put those restrictions out there, they don't really mean a whole lot to you. They're just there, I don't want to say to confuse you, but they're there to validate that those are working functions. So that's typically, anytime they tell you something like that, that's it. So now I just got to show their inverses. So I've got to show h of k of x. And why'd you do that one first? I don't know. Don't have to. I can do the other one. I can do k of h, but I got to do both. So h, instead of x squared, now I'm going to have the square root of x minus 10 squared plus 10. And we need to be able to follow that. So it's x squared plus 10, and this is going in place of that x. And that's really, really nice, because if I square the square root, it becomes just the x minus the 10. And the x minus the 10 plus the 10 will equal x. Now I've got to flip-flop that. So I did h of k, I got to do k of h. And k says I have the square root of x, and x has to be x squared plus 10, but then I got to minus the 10. And that's really, really nice, because the plus 10 and the minus 10 go away, and I have the square root of x squared, which equals x. And now I have shown that they are inverses of each other. Any questions about that? Like I said, I'm reminded, I know 2 years ago that was a free response question. I know that it was on the non-calculator section. Here again, guys, they're trying to confuse you a little bit, where x does not equal 0 and x does not equal 4. I know that x can't be 0 because of that right there. Because if x is 0, that thing's undefined. And same thing over here. I know that x can't be 4 because if x is 4, that thing's undefined. So they're telling me that just to make sure that these are defined. That's what they're telling me. It doesn't really mean anything to me. I still got to do n of p, and I got to do p of n. Okay? All right. N of p. N 6 over, now it's no longer x. Holy cow, this is going to be nasty. 6 over x plus 4. This is where I'll start seeing some students do some equals x. No, that didn't work. Got to get a common denominator over here to combine. So this is 6 over x. This is going to be 4x over x. Yep. And I forgot the minus 4. Oh, well, there you go. See there? That's what happens. Thank you. Saved me a lot of fixing. Now I don't need common denominators. You'll see, I forgot this minus 4. Or where is it? Where'd I forget it? Here? Yeah, here. That's really nice now, because now they do go away. And I got 6 over x. And this is 6 over 1 over 6 over x. And if I flip and multiply it, that x goes up there with that top 6, and that 6 goes down there with that 1, and then the 6's do cancel, and you are left with x. Whew. Thank you for catching that. I've only done half of it. Got to do the other half. I've got to do p of n. 6 over x minus 4 plus 4. Multiply and flip. This is 6 divided by x minus 4. So the x minus 4 goes up here with this, and the 6 stays on the bottom. I don't know if y'all know. At some point, you got to get good at that. Where can I put that at? This is what do you call it? Tangent, side note. I don't know how many times you guys have seen this a whole lot. What was it? 6 over x minus 4, right? Okay. So you got to get pretty good at being able to put that up here with this and leaving that on bottom. And how that works is because this is really 6 over 1 over 6 over x minus 4. It's a division problem divided by a division problem. And you know when you divide fractions, you flip and multiply. When you have 6 over 1 divided by 6 over x minus 4, you change that to multiplication and you flip that. Well, it's a lot easier when it's written like this because you're just going to flip it and multiply it. That means that x minus 4 is going to go up there and the 6 is going to go down there. So you kind of have to start seeing that a lot easier that way than this way. And I forget that a lot of times y'all don't do the whole lot of that in Algebra 2. Okay, go back to here. So now this will become 6. I'm not going to multiply it. It's going to become 6x minus 4 over 6, and you still got that plus 4. And now you can see those 6's go away, and you're left with x minus 4 plus 4. All right. You guys will have practice on that on your homework. That's going to be one of your harder tasks. It'll be one of your harder tasks on your homework. And again, it's one of your test questions. So whatever you got to do to make sure you know how to do those homework questions. All right. Part 2. I'm not going to get caught this time. If f and g are inverses, then g could equal the f inverse of x. So in other words, g is equal to the inverse of f. If x and y is a point on the graph of x, then yx is a point on the graph g. Yep. Yep. It's in the file cabinet. I don't know. Yeah, open up that file cabinet. Yep. It's open already. Pull it, pull all the way back. It should be the very last thing. That might be it sitting up. Sure. Nope. Don't do that one. Yep. That say 2.8? That says 2.8? Yeah. Sweet. Okay. So they're kind of just looking at different ways of rewriting this. With inverses of all x's, y values are switched, so the graphical behaviors of are switched. For example, the domain of f is the range of the inverse. That's something you kind of need to understand, right? If this domain, we have this domain in this range, and so the inverse is now switched to where this range is now this domain, and this domain is now this range, right? Because all the y's and x's get switched. A continuous function will only have the inverse if it is strictly increasing or strictly decreasing. If a function changes from increasing to decreasing or vice versa, it will not pass the horizontal line test, and inverse relation will not pass the vertical line test. I don't like ever saying that because y'all get in such a habit of this. All right, so let's just look at these questions. These are starting to be, these are like multiple choice type questions. You could see, you'll see one, if not two of these, but one of these on the AP exam. Let f be a continuous function, so it's continuous. Continuous means you, wherever you start your pencil, it goes on, okay? So it's continuous. Let g be an inverse of f such that g equals f inverse of x. Find the following values if possible. So I need to find f of 0. I don't think this involves anything inverse. So f of 0, f of 0, f of 0, f of 0 is 1. If f of 0 is 1, then I got to find f of 1, which is negative 1. Good enough? Yep. They just want me to find f of 0. I mean, that's from 2.7. That's not even like an inverse question. G of negative 3. Oh, this is an inverse question because what do you know about G? G is the inverse of f. So if G is negative 3, that means I'm inputting a negative 3 on the original's output. So G of negative 3, I'll find negative 3. G of negative 3 is actually the original's input, which is 4. Because G is the flip of the x and the y's. So that's where it starts to become a little bit more tricky. G of 6. That means I got to look at the original's y. So I'll look at the original's y. I'll find that 6. That will equal negative 3. Because G is the inverse. So this is the y of the original. All right, now we want, holy cow, now I want G of negative 1, and then I want G of that. G of negative 1. G of negative 1 is 1. And then I got to find G of 1, which is down here. So it's 0. Yep. G of negative 1 is 1. G of 1 is still the inverse. Yeah. It's okay. You're good. Y'all know I make one mistake a year. Everybody okay? Oh, they write this one. I hate it when they write it like this. F of negative 2. So I got to find f of negative 2 first. So f of negative 2 is 3. F of negative 2 is 3. And now I got to do f inverse, which is the same thing as g. G of, what was it? Negative 3? 3. 3. Oh, it's just back to negative 2. Huh? I tied my shoe and then I untied it. I inputted a negative 2. I outputted something. And whatever I output, that becomes my input of a negative 2 again. F inverse of negative 3. That's an output of a negative 3. An output of negative 3 gives me an input of 4. Yes, no, maybe? Wait till they give you a graph and a picture and a table, and you got to try to figure all that out. Here's a graph. The function k is defined from negative 4 to 11. Let k inverse represent the inverse of k. What is the minimum value of k? K is the regular function. The minimum value looks to be negative 3. Negative 3 is the minimum value right there. What is the minimum value of the inverse? So that's the smallest x, which is negative 4. Because that point, negative 4, negative 3, is going to get switched to negative 3, negative 4. So if I switch that point to negative 3, negative 4, there's the new point. Okay? Find K inverse of 6 and K inverse of 4. So K inverse of 6, that's the Y value. And if that's the Y value, I need to find when Y is 6. And when Y is 6, X is 11. When Y is 4, X is 6. Uh-oh, sorry. Beautiful. Almost done? Almost done. Bear with me. Okay. Got another graph of f. Graph of f. The function f is denoted from -2 to 8, as shown above. Let f inverse represent the inverse of f. What is the maximum value of f inverse of x? Well, the maximum value of f inverse of x was I need the maximum x value, because the maximum x value is now the new maximum y value. So the maximum x value is 8, because that point is 8, -3. And if that point's 8, -3, my new point is -3, 8. And so that has to be the max, 8. Find f inverse of 3. That means output was 3, input is a 2. F inverse 1. Output is a 1, input is a 3. Output is a 1, input's a 3. What is the domain of F inverse? So the domain of F inverse is the range of the F. And the range of the F is from -2 to 8. And if the range is, so the domain of F is from -2 to 8, that has to be, oh, they want the domain. So I got to look at the range. The range goes from -3 to 7. So the range goes from -3 to 7. Therefore, the domain has to go from -3 to 7. Good? I've got G, I've got H. Now we're starting to get into some questions. I want to find G of H of X, or of 6. That's easy. That was 2.7. H of 6, H of 6, H of 6, 10. Oh, there he is. I bet that's him. Yes, ma'am.
Hey there, I need Grace Combs to
Oh.
come check out with me in the North office.
She's on her way.
All right, thank you.
Okay, bye. Bye, Grace. You get your homework? Okay. 10, -1. Okay, so that's not hard. Here we go. H of 0, H of 0, H of 0, H of 0 is 3. Now I want G inverse of 3. That means I need the Y of 3. 4. They start to get a little confusing. You mess with your brain, switching X's and Y's. Almost done. Yep, 2 more. G of 8. G of 8. G of 8 is 0. This is 0. H inverse of 0. That means I got to go to 0 and I get -1. Everybody see that -1? Y'all okay? And then the last one, inverse. G inverse of -1. -1. 10. So that's 10. H inverse of 10, 6.